Thank you, moderator, Engineer Christian Inti. Good morning, colleagues, and a very warm welcome to this morning presentation. The privilege is all mine and not yours, as you said. It is humbling to make this presentation, which is on the topic project implementation, pavement design considerations. So, moderator, let me start by stating that the growth and expansion of the Ghanaian economy in the past decades is due to a large extent the road network that we have. There are various transport modes in this country in the form of roads, air, water, and rail. And out of these, roads carry 95% of people, goods, and services. So if we hadn't developed roads to this extent, the economy would not have been this good. So it's very important that we know what to do when it has to do with road pavements. Now, the role of the engineer in this concept is to design, construct, and maintain the system in an efficient and economical manner. To do this, we have specific objectives. The first one is to recognize the different pavement types. The second is to understand the role of pavement and soil layers. The third is to identify the key factors that affect pavement performance. And the fourth is to understand important drainage considerations. So, what are pavement types? Pavement can be grouped into four broad categories based upon structural characteristics. The first is rigid pavement, and these are Portland concrete slabs that distribute wheel loads over large areas. They are normally placed on top of an existing subgrade material, which is probably stabilized. It can also be placed over a sub base if needed, or a base course if needed. But more often than not, in this country, we only have the concrete on the subgrade material. The next is flexible pavements. And they are those that deform symmetrically as they distribute wheel loads through the various layers of materials of increasing strength from the subgrade to the surface. All the various types of bituminous surfaces which do not have any PCC slabs are considered flexible pavements. Now, a flexible or bituminous pavement structure consists of all categories above a prepared subgrade soil or foundation. It may consist of a surface dress made up of a primer seal and seal, or asphalt concrete placed over an aggregate base and or subbase layers. Unbound or aggregate surface roads, which are gravel roads, can perform very satisfactorily for low volume. They consist of one or more unbound gravel layers, including the surface. It is good to undertake routine maintenance in order to preserve them, and they are sometimes referred to as unpaved. The third one is brick, cobblestone, or paving blocks. Now, from a structural point of view, these are flexible pavements. But they have unusual characteristics, and that warrant them to be treated separately. They are those in which the bricks or stone blocks are embedded in sand, quarry dust, bitumen, or Portland cement slurry, or Portland cement slurry bedding on aggregate base or subbase material. So in effect, it's like you prepare your pavement layer, your subbase, your base, and you put the PCC slurry, bitumen, quarry dust on top of that, and then you place your paving blocks or cobblestones. And the final ones are composite pavements. These are flexible composite pavements. These are flexible pavements that these are concrete pavement, but have flexible pavements that are on top of them. So they have been overlaid with flexible pavements. A cobblestone pavement, which is also overlaid with asphalt, is also called a composite pavement. Now, there are certain factors that we consider in selecting the pavement types. And these are the terrain, where the road is passing, you determine which kind of pavement you need. If you have to use stabilized material, or you have to use existing material, or you have to have an embankment, the terrain will determine that. The materials that you use to are very important, because it's not economical to be importing materials from long distances. That will escalate the cost of the construction. So it's very important to construct the materials which are close by. Secondly, the population. Now, you cannot have unpaved roads in highly populated areas. That comes into play. And finally, politics. That we cannot run away from. Politics comes into selecting the pavement types for any road pavement that you want to design. Now, what is the role of the pavement and soil layers in road pavement? Now, the surface layer of a road pavement which is exposed to traffic, must be tough to resist distortion and provide a smooth riding surface. It must be waterproof, where it can shed surface water to the roadside, therefore protecting the total pavement, entire pavement structure, and the subgrade from the bad effect of moisture. It must also resist wear caused by traffic and retain its anti-skid properties. The base and sub-base layers are normally called unbound layers because they are just natural material. They are considered structural members of the pavement, and then they, in conjunction with the surface, distribute loads over a relatively large area of the subgrade. The base is the support layer immediately below the surface, and it is greater in strength than the subgrade. The subbase is a term if you have several bases. A subbase is a term that is given to the lowest base material, which is on top of the subgrade. The subgrade is not considered structural, but the top 15 centimeters is compacted prior to replacing the base or subbase on top of it. On this, you will see the loading imposed by a wheel of a vehicle. Now, the function of a pavement structure is to support traffic load on the pavement surface and to spread or distribute the load to the subgrade soil without overtaxing its strength or those of the various overlying pavement layers. To perform this function, bases and subbases must be built with adequate internal strength. Furthermore, they must retain these properties throughout the life of the pavement. Hence, it is important to consider routine maintenance and good drainage. Now, if you look at this slide, you will see that there is a lot of pressure from the tire on the surface. And as it goes down, it is dispersed over a wide area. So by the time it reaches the subgrade, the effect of the load is reduced dramatically, the bare minimum. Okay. Now, the next point to consider are the factors that affect the performance of our road pavements. And these are traffic loadings, subgrade soil support, material construction, structural characteristics, construction and maintenance variation, moisture, maintenance and rehabilitation programs. First, when pavement were first introduced, the proper thicknesses were determined by guesswork, rule of thumb, or experience. Now, these were similar to what was happening in the old times, where people have to do masonry works, design arches, iron, steel members. They decided that this has worked before, so to work again. Now, these early techniques have long since led to more fundamental engineering analysis. And similarly, the structural design of pavement has evolved into a more reliable engineering-based procedure. These factors are the factors that help in design or evaluating the pavement, and they are the ones that I've just mentioned. Traffic loading refers to cumulative loading that are sustained by a pavement over the course of its life. Thus, poor traffic analysis means that the pavement may be under-designed if traffic is underestimated, or uneconomical if traffic is overestimated. Now, the determination of a uniform value of traffic loading depends on several factors: the average daily traffic, the future projection or the traffic growth rate, the distribution of tracks, the lane distribution, that is the percentage of tracks which is in the design lane, the direction distributional factors, and load equivalency factors, which are used to convert the distribution of the vehicles into an equivalent number of load applications that can be used for design. Now, if you look at this slide, you see that on top of it, we have a lot of vehicles. There's a serious traffic jam. And underneath that, we see another, it's an automated track, but there's no traffic jam. Now, for pavement design considerations, the traffic volume is not too important. The important thing is the traffic loading that causes the damaging on the pavement. You can talk of the volume when you are talking of the capacity, but for pavement design, it is a loading. And I would like to use this to show you what I mean by the loading. You see on the left, it's a lady's high heel shoe, and that is putting a lot of pressure on the ground. For that matter, if it steps on you, you will feel it. Whereas if my shoe on the right steps on your feet, you will not feel it much because the load is distributed better than the pointed load. This talks directly explains the effect of overloading at the point on the road. Now, all the previous values I said, and derive the cumulative equivalent single axle load application that we sustain by the design lane. So on the left side of the screen, you will see vehicles that are severely overloaded. That is telling you that if you have things like this on your road, then probably you may not last long when you do a design. This has to be controlled. Now, one has to convert the mix of traffic to a uniform measure through the load equivalency concept. Now, the load equivalency concept is a relationship between particular loads or particular axles, and generally, it is, we know that the damage of the axles is not linear. If, for example, one load passes and another load passes, if one load can cause a damage, let's say 1, a second load passes, and that load is twice the previous load, it doesn't mean that the damage will cause will be 2 times. It will cause what we call the fourth power law. And that means you have the damage is between one load and another is determined as a function of the ratio between the 2 loads. So the next slide will show you that the axle equivalency factor of a particular load I, which is divided by the standard load raised to the power 4.5, would show you that if you have, for example, the example shown below, you have a standard load of 8.2 tons, and then another load that is double that passes over the road. It means that the damaging effect will be 20 times the one that is standard, which means if one axle weighing 16 tons, double the normal standard load passes, it will cost 20 times the damage that one standard load will cause. And at the same time, if you look at the second example, a load of 7 tons, if that passes, it will cause half the damage of the load of a standard ton. So one is very, very particular about the damaging effect of traffic. So it is very, very important to be able to estimate the axle equivalency factors and the axle damaging effect of the axles that we have on our roads. Now, the next one to look at is subgrade soil support. Now, all pavement structures rely upon the natural subgrade soil for support. The function of the road pavement is to distribute the wheel load as much as possible, but the natural soil must ultimately carry all the load. Now, from a pavement design and engineering point of view, there are two general characteristics that are important. One is the classification of the soil, and two, the strength of the soil. Now, soil classification is important since it gives us a good idea of the grading and constituents of the in-situ soil material. There are two methods of soil classification. The first one is the unified system, and the second one is the ASHO system. For road construction, the ASHO system is generally used. The second and the most important is the soil strength, because the subgrade soil is the one that is going to take all the load. So the soil strength is very, very important. And measures of soil strength can be determined in the laboratory using the CBR method, the soil support method, the unconfined compressive strength method, the resilient modulus method. When these things are determined, they go in helping to do a proper design of the road pavement. The next factor that we consider are the materials that we use for construction. And these are what you can see on this screen in front of you. The first one is bitumen. The second is Portland cement. Number three is soils and aggregates. We also need water. We still for reinforcement, and sometimes you need additives. The next component that we discuss in terms of the parameters that affect the pavement performance is structural characteristics. Now, these refer to various physical characteristics of the pavement structure. They have an impact on pavement performance. Now, the structural characteristics include the number of layers and their thicknesses. Also, it includes lateral support, reinforcement type, if it's a concrete pavement, percentage of joint spacing and geometry, as well as load transfer. Now, there are properties that can be controlled during the design and construction process, and they provide another means through which the engineer can exercise some control over the long-term performance. For example, if you are designing for an asphalt concrete material, you can decide to use a structural characteristic between 0.4 and 0.3. The engineer can choose depending on the flexibility of the asphalt that he wants to use. You can also choose in terms of crash stone base, whether you use a value of 0.14 or 0.17, depending on whether it's a natural gravel base or a crash stone base. So this gives the engineer control over the design. The other factor that affects pavement performance is the variation that occurs in construction and maintenance. Now, failure to obtain proper compaction, moisture conditions during construction, the quality of paving materials, and as-built layer thicknesses directly affect performance. That is why during construction, there is always quality control and quality assurance. As long as you are constructing, you are testing to be sure that what was designed is what was being put on the road. So on this slide, you can see we have, for example, two roads, one with poor control and the other with good control. Obviously, it is very difficult to have a road that is constructed which is of poor control, which would have met specifications. Obviously, when the road is being constructed and tests are being conducted, it must be of good control. But this for discussion purposes. If it is of poor control, it means that the performance will be less. And in this graph, you can see about 4 years less in service life compared to the one that has good control. The next one is maintenance operations. The variability in maintenance operations is similar to that of construction variation. So what it means is that whilst we are designing a road, we must have in mind that we have to do maintenance. For example, if you have designed for a service dress road for 15 years, we have to know that by 7 to 8 years, when the IR value, the roughness value has dropped to below above 6, we have to do resealing. If we do this, it means that our pavement will meet the service life for 15 years. If we don't do that, then after 8 years, 10 years, the service life will drop and drop very, very quickly. The next important factor is moisture. Now, moisture can have perhaps the most influential effect on the pavement performance. The moisture can enter a pavement structure through cracks and holes in the surface. It can enter laterally through the subgrade soil and from the underlying water table through capillary action. The presence of water or moisture in the soil and underlying layers of the pavement structure weakens those materials and thereby reducing their load carrying capacity. Since it lubricates the soil particles, it also increases the potential for slope failure on highway embankment. Water on the pavement can create problems for the bituminous layers. If water enters asphalt concrete structure or surface dress structure, it causes what we call stripping. That is the removal of the stones from the bitumen, which will lead to cracks and potholes. So moisture is very, very important and has to be considered when one is designing road pavement structures. The final one is the maintenance and rehabilitation program that one has to draw for the pavement when one is doing a design. Now, the condition of a road pavement is not constant. It deteriorates over time due to the factors that we have discussed previously. Now, the deterioration is also dependent on the levels and types of maintenance and rehabilitation that are conducted. The maintenance refers to any activities that are performed on the pavement that is intended to preserve its original service life or load carrying capacity. Examples of maintenance activities include patching, that's pothole patching, crack repair, joint sealing, and seal coats, etc. If these are performed on a routine basis and as the demand arises, the pavement should provide a desired service life, assuming that traffic and environment were adequately characterized. If these activities are ignored or deferred, the pavement will probably not last long. But on the other hand, if these activities are performed before the demand arises, which is preventive maintenance, the result will likely be both an extended service life and improved overall performance during the life of the pavement. Now, the final point in this is the rehabilitation that one has to undertake. And rehabilitation refers to an activity which is performed to extend the service life or load carrying capacity of the existing facility. Examples are overlay, grinding and milling, slab replacement for concrete pavements, resealing for bituminous surface roads, surface dressing, and then re-graveling for gravel roads. Thank you, Mr. Moderator.